Okay, 3.1b is on two-step equations with our algebra tiles. So, let's do one review problem. Here, letter A says n plus 11 equals 15. Well, what plus 11 equals 15? 4 does, so n would be 4. So here's the thing. We could use mental math to solve a lot of these equations with our algebra tiles, but what we're trying to do is build a conceptual understanding, okay? And to figure out strategies we can use when we can't find the answer using mental math, okay? Because as we keep going in math, things are gonna become more rigorous, and so what we need to do is be able to have strategies to use, like I said, when we can't solve something through mental math. So for example, B, 3 times y equals 15. Well, I know that 3 times 5 is 15, so y must be 5. That one I could do in my head. That was my mental math. But C, 2/3 of x equals 4. Well, maybe you don't know 2/3 of what number would be 4 off the top of your head. And that's the type of problem that we need strategies for. So when we're looking at our algebra tiles, we're really thinking about what strategies can we use to solve these, as opposed to just using mental math to solve them. So example 1, we want to balance the scale to solve for x. We have 2x plus 1 equals 5. Well, we want to start by getting x by itself. So get the x's by itself. In other words, we want to isolate x. Isolate means to get it by itself. Okay, so in order to do that, I would have to take 1 away from both sides. Remember from yesterday that our 1 minus 1 cancels out to 0. Okay, so then what I'd be left with is 2x equals 4 ones. Right, so here I've got 2x equals 4 ones, and I want to figure out how much would 1x be. Well, I could split this, in other words, divide it by 2, okay? And that shows me that if 2x's equals 4, 1x equals 2. So x equals 2 would be our answer. Example 2, we want to write an algebraic equation to represent the algebra tiles and then solve. So here we've got x plus a negative 2, in other words, x minus 2 equals 1. Okay, remember we want to isolate x. It's going to be easier to visually see what x represents if our x's are on one side and then all of our squares, our ones, are on the other. So if I've got 2 negatives, okay, in order to cancel those out, I would need a positive. Right? 1 positive and 1 negative cancel each other out. So since I have 2 negatives, I need 2 positives. And then anything I do on one side, I have to do on the other. So since I added 2 positives on the left, I have to add 2 positives on the right. So now what are we left with? We're left with 1x is equal to 3 ones. Well, if 1x is equal to 3 ones, there's our answer. For the equation x minus 2 equals 1, x would need to be 3 in order for that to be true. Okay. Example 3, we want to write an algebraic equation to represent the algebra tiles. So we have x plus 2 equals 3. Well, again, we want to start off, I'm going to write it off to the side actually, equals 3. We want to start off by getting our x's by itself. Okay, so right now there are 2 positives. Well, I could add 2 negatives, okay, because then my 1 minus 1 cancels out, 1 minus 1 cancels out. Since I subtracted 2, okay, that's what we're doing, we subtract 2. On the left, I want to subtract 2 on the right. So then 1 minus 1 cancels out, 1 minus 1 cancels out, and all I'm left with is an x on the left and 1 on the right, which means that x equals 1 is our answer. Let's do a couple more. Use algebra tiles to model and solve So here I've got 2x minus 3 equals negative 5. I want to get my x's by themselves. So since I have 3 negatives, I would need to add 3, right? I would need 3 positives. So I'm adding 3 to both sides. And then what happens? Well, 1 and negative 1, 1 and negative 1, 1 and negative 1 cancel each other out. So we're left with 2x's is equal to 2 negatives. Okay, well, then I want to split this, right, into groups of 2 because I've got 2 x's. So if I split this in half, I see another way to say split in half is to say divide by 2. I see that if 2 x's equals 2 negatives, then 1x equals 1 negative, which means that x equals negative 1 is my answer. That's the x value that would make this equation true. Last example, we have 2x plus 2 equals negative 6. Well, again, we want to get our 2 x's by themselves, so I would need 2 negatives, right? Because then a positive and a negative cancel out, a positive and a negative cancel out. So then I need to add 2 negatives on the left. Well, now what do I have? I have 2 x's equals 1, 2, 3, 4, 5, 6, 7, 8 negatives. Okay, so if I draw that out, I've got 2 x's and 1, 2, 3, 4, 5, 6, 7, 8 negatives. So since I have 2 x's, I could divide by 2. Right, split this into groups of 2. So if 2 x's is 8 negatives, that means 1x is 1, 2, 3, 4 negatives. So x equals negative 4. That's the x value that would make that equation.